Good afternoon. I am totally freaked out. So thank you for coming. Thank you for being here on a last day afternoon. And thanks for being awake. Hopefully you're still awake by the end. I'd like you to take a moment to think back to the first time you wrote an active record association. Might have been recently, might have been many years ago. Did you feel confused or maybe impressed by how much could be accomplished with so little code? I remember my first time well. I was a brand new programmer working through the Hartle Rails tutorial. And I wrote my first associations having really no idea what I was doing. I didn't know that has many and belongs to were Ruby methods. Thought that they were these special Rails macros. Thanks for the laugh. I was awestruck when I realized how much behavior was defined by these brief lines of code. Belongs to repository here, for example, defines 8 different methods for you, methods for reading and writing the repository, for creating new ones. But it also comes with a heap of behavior on top of that, presence validations, a caching mechanism, hitting your mic with your thumb. This is a ton of behavior to get with just a few lines of code. I think this is a good example of what people sometimes call Rails magic. Now, Rails magic is fantastic. Rails provides all this behavior for us without us having to really think about it. It performs a kind of vanishing act, like what we saw with Zeitwerk in the opening keynote. The details are hidden away out of sight, so you don't have to think about them. And this allows you to focus on the parts of your application that make it unique. But Rails magic comes with a negative side as well. Sometimes when things are confusing or not working the way you're expecting, it can be tempting to throw up your hands and say, well, I don't know, I guess it's just Rails magic. But instead of brushing off that confusion, I think it's worth digging into the confusion to uncover the source of the sorcery. Because if Rails is indeed magic, I think that makes all of us magicians. Now, I've been watching way too much Penn and Teller Fool Us while preparing for this talk. But it seems to me that when a magician sees a trick that confounds them, they like to study how it works and incorporate that knowledge into their own repertoire. So we can do the same kind of study with Rails magic. And that's what this talk is about. We're going to study some of the parts of active record associations that I've found confusing or that have interested me, with the hope that pulling back the curtain a bit will help you to use associations more effectively. I'm also hoping that this talk will encourage you to continue these studies beyond what you learn here. I'm Daniel Colson. What am I going to say about myself? I was formerly on the Rails issue team, maintainer of FactoryBot, and nowadays I like to spend my time helping other folks get involved in contributing to Ruby open source. So if that's you, come talk to me. My various handles are esoteric references to my former career as a professor of music. Now I am on the Ruby architecture team at GitHub, where I've had lots of opportunities to study active record associations. Now, if you're really interested in active record associations and you're interested in hearing more about some experimental patterns that we've been exploring at GitHub, the very next talk in this room is about that, so you may want to stick around. All right, for our study, we're going to define our own simplified has many and belongs to methods that are going to be based closely on the design of active record itself. So we'll start out with a bit of metaprogramming as we define our belongs to method. Then we're going to introduce this class called a reflection that's going to help us define our belongs to in a generic way. Once that's complete, we're going to add on a caching mechanism. Then we'll move on to the has many method, and we're going to bump into this other part of active record called the relation. And then finally, we'll add on one more feature called association inverses. So first up, metaprogramming. For the example here, we're going to have a pull request model and we're going to define a belongs to association called repository. So the first time I saw this, I had no idea that belongs to was a method call. So I'll just rewrite this ever so slightly to make that more explicit. So we're calling the belongs to method on self. Self here is the pull request class. This is a class method. And it takes an argument of the association name. So we can define a class method. That's not too hard. Looks like that. Def self.belongs to, and it takes an argument of the association name. So that's the easy part. Now the fun part, metaprogramming. When we call this belongs to method, we want it to define a reader and writer method for our association. So we're writing a method that's writing other methods. That's what metaprogramming is all about. And we want the methods that this belongs to is going to define to be based on the name passed into the belongs to. So let's look at our reader method. Let's say we've got a pull request, and let's say that it's got a repository whose ID is 42. I want my belongs to define a reader method pull request.repository that will return the repository object whose ID is 42. So in other words, I want the method to return the repository whose primary key matches the pull request's foreign key. Now, when I'm doing this kind of metaprogramming, I find it easiest to start with a concrete method and then work toward a generic version. So this is what the reader would look like if I just wanted it to work for repositories and not for any possible association. I can use active records where method to find the repository object whose ID matches the pull request. And there's only going to be one repository with a given ID, so I call first to return that one record. And the writer method. Let's again say I've got a pull request whose repository ID is 42. And I've got some other repository in memory with an ID that doesn't match. I want my belongs to define a method repository equals that takes this repository and will update the pull request's repository ID to match the repository that I passed in. And so I can write that method without too much trouble. Repository equals is the method name, takes an argument of the repository, we read the ID off of it, and then we set the pull request repository ID. So right now, this only works for associations called repository. We want this to work for any possible association. And we can do that by using Ruby's define method. So define method takes as an argument the name of the method that you want to define. So now if I call belongs to with this argument repository, I'll get a repository method, and with a little string interpolation, a repository equals method. But this now works for any possible association name. I get a reader and a writer method. However, I've also hard-coded some stuff into the body of these methods. There's the repository class, and there's the primary key and the foreign key, ID and repository ID. So again, if I want this to work for any possible association in any possible class, I need to get these in some kind of generic way. So basically, I want code that looks like this. But where do I get these values from? What I have available when I'm declaring my belongs to association is the model that I'm in this case pull request, and the name of the association, which in this case is repository. So how do I get from that information to this class primary key and foreign key I need? I've heard folks say that magic is all smoke and mirrors. So what if we could solve this with a new class called a reflection? I know, that was a cheesy joke, but sorry. I worked hard on that. This reflection class will store metadata about the association and then let us reflect on the association or ask certain kinds of questions about the association, like, hey, what's your primary key? What's your foreign key? What classes are you associated with? This reflection is going to get initialized with the active record model that you're defining your association in and the name of the association. In our case, that would look like this. Pull request is the model that we're in, and repository is the name of the association. Then we can define 3 methods on this reflection to get those pieces of information that we need. So the class method, in this example, we want it to return the repository class. You might be able to see that that's kind of related to the name of the reflection. So I need a class method that will transform this reflection's name into the corresponding constant. Active support comes to the rescue. I can use these methods camelize, which will take a snake case string and turn it into a camel case string. And then I can call constantize, which will take that camel case string and turn it into the appropriate Ruby constant. It finds it using Ruby's const get. Once the class method is defined, the primary key method is actually pretty simple because active record models have a primary key method on them that returns the appropriate value. So I call class.primaryKey. That one's pretty easy. And then for the foreign key method, in this example, I want it to return repository underscore ID, which again, you can see is kind of related to the reflection name. I just have to tack underscore ID onto the end of it, which I can do with a bit of string interpolation. So with those 3 methods defined, now at the top of my belongs to, I can initialize one of these reflections. I can get the class, primary key, and foreign key off of that reflection. And all of a sudden, my belongs to methods fall into place. I now have a way to get these values. So we did it. This works for any class, and it works for any association name. I feel like I earned some water, yeah. All right, now we add on another feature. So we're going to add on a caching feature. Not that kind of cache. So currently, without caching, if I call the repository reader method twice in a row, I get different objects each time. Having multiple copies of the same repository object in memory is inefficient and can result in inconsistent data. So for example, if I change the name of one copy of this repository, the other copy in memory won't reflect that change. And so I end up with inconsistent data. If I then render, say, the repository name on a page somewhere, I'm going to get different results depending on which of these copies of the object I use. And this sort of thing can lead to subtle and confusing bugs. So we're going to introduce a caching mechanism. And the logic is going to live in this new class called association. Whereas the reflection class stored class-level metadata about the association, this association class is going to have the instance-level data. So the owner here is going to be an instance of a record that we're calling an association method on. And then the target is going to be the records that we actually load for that association. And then we'll use this loaded flag to figure out whether we still need to load the target. This association class is going to be responsible for everything to do with loading records. So we're actually going to move the belongs to reader and writer method bodies that we wrote a moment ago out and into this new class. So I'm going to do a little cut and paste here, cut that out, define these new methods in the association called reader and writer, and paste what I just cut into there. Then I'll go back to the belongs to definition and call these association reader and writer methods instead. So I haven't changed anything yet, I just moved some code around. I also cheated a little bit because I never actually defined that association method. But it basically, every record has a cache of these association objects, and you can look them up by the name of the association. So for our pull request repository association, we'd get back an object that looks like that. The owner is the instance of a pull request, and the association will start out as not loaded. So now to get our caching mechanism working, we're going to add a conditional to the reader method. That conditional is based on the loaded flag, which is going to start out false. So that's going to send us to the else branch of this conditional. The else branch will do the loading that we did before, and then take the record that it loads and set that as the association's target. It'll also mark the association as loaded. So now, if I call this reader method a second time, Loaded is true, and so I don't have to load the record again. I can use this target that is already in memory. One little detail here, to ensure that the association target is always up to date, we also need to set it whenever we're writing to the association. Otherwise, we end up with stale data in the cache. So great, we've now got a fully functioning caching mechanism. Now if I call this repository reader method twice in a row, I get the same object each time. And so there's only one copy of this repository in memory. That means that when I update one, I'm actually updating both because they're the same exact object. So no more problems with data consistency. This is great. We just eliminated a whole bunch of bugs, and we made our application more efficient. And Rails does this for you for free. You never have to think about it. It's great. Okay, relations. We're going to, yeah, okay. Get excited. It's not that kind of relations. I know, I put the emoji there, but whatever. Now into the has-many association. The has-many association is going to start out very similar to belongs to, but we're going to bump into this other part of active record called a relation, and it's going to get a little complicated. So bear with me, we'll get through it, and I think it ends up being pretty neat at the end. So. The example we use here is kind of the other side of the example we used a moment ago. We've now got a repository model. We're defining a has-many association called pull requests. So before we were working with pull requests model belongs to repository. It's kind of the opposite. We can define our has-many class method with the exact same code we ended up with for our belongs to. Great. We're using define method. We're calling the association reader and writer methods. But of course, it's not that simple. We can't just reuse everything. There's different association classes. There's actually different reflection classes as well. I'm not going to get into that too much. The belongs to association and has-many association classes are going to work fairly differently. So let's take a look at the reader method for these two classes. The belongs to association reader that we ended up with looked like this. It had our caching mechanism built into it. And then the way that we loaded records was by finding the records whose primary key matched the association owner's foreign key. And then we called first to get back a single record. So we can get pretty close to a has-many association reader with just a few small changes to the way we load the records. Because we're kind of on the opposite side of the relationship here, we swapped the position of the foreign key and primary key. So we're now loading records whose foreign key matches the association owner's primary key. And then instead of calling first, we call 2A to get an array of records. This is a collection instead of a single record. And this is pretty good. We can call repository.pullRequests. That'll load the associated pull requests for that repository. And we get back an array of pull request objects. And we've got our same caching mechanism. So if we call the method again, we get back the array that's already in memory, and we don't have to load it again. So this works. But it's not quite as magical as what we get with a real active record. What I really want to do here is not return an array of records, but return something called an active record relation. So what is a relation? Relations are what you get if, for example, you call the where method. Now, we've called the where method before, but we immediately called .first or .2a on it to get a record or array of records. If you just call the where method without chaining those things on, you get back this thing called an active record relation. I think of a relation like a super-powered array of records. It has all these additional features built on top of it, and I would really like to get those features for my has-many association. One of the features is lazy loading. So if you just call where, it doesn't actually load the records. It's not until you call a method like 2a, for example, where you need an array of records, that the relation will perform a SQL query and load those. So that's neat. Relations also have a bunch of methods that standard arrays wouldn't have, like a create method. The create method allows you to create new records using the conditions from that relation. And there's a whole bunch more built into these relations, and probably enough for a whole separate talk on just that. So wouldn't it be cool if when I called repository pull requests, instead of getting back an array immediately, this is sort of like eagerly loaded array, I could get back a relation with all these features. And we can do that, but there's a catch. We've got this association caching mechanism. So if I want this association caching mechanism to still work, then when I call a method like 2a on the relation that forces it to load records, it needs to somehow load the records via the association so that the association can be marked as loaded and can put those records in its target. But there's a problem here because relations are a totally separate part of active record, and they don't know anything about associations. So the arrow I've drawn here doesn't make any sense. There's no way for a reflection to delegate certain behavior to this association object that it doesn't know exists. Unless we introduce a new type of relation, a subclass of relation called CollectionProxy, that gets initialized with a reference to the association. Then this CollectionProxy could delegate certain behavior to that association object. Okay. So let's rewrite our hasManyAssociation reader method to return one of these collection proxies. So now we've got all the relation features. Collection proxy is just this special type of relation. And we're going to take what used to be in the reader method and put it in this new method called loadTarget. We'll mention this loadTarget method again in a moment so you can remember the name of that. So now repository.pullRequests returns a collection proxy, and the collection proxy has a reference to the association. If I now call a method like 2a that forces the collection proxy to load, instead of loading the records directly like a standard relation would, it's going to load them via this association object by calling its loadTarget method, the one we just defined. And so that way the association will be marked as loaded. It'll set the target to be those records that were loaded. Because repository.pullRequest is a collection proxy, we also have methods like create. But again, instead of doing it directly the way a relation would, the collection proxy is going to delegate that work of creating a new record to the hasManyAssociation. And that's going to allow the association to update its target with the newly created record. So we won't end up with a stale cache. And this is pretty cool. This is specific to the collection proxy hasManyAssociation relationship. Relations don't know how to do this sort of thing at all. Then if we call 2a again on the collection proxy, it again delegates that work to the association using the loadTarget method. And since the association is already loaded, it returns a target it's already got in memory. I feel like I was supposed to celebrate that a little bit. I don't know. Yeah, some more water. Oh yeah, right. It's like, this is cool, right? It's complicated. I know it's complicated. And if you didn't follow all of it, that's okay. This is a complicated part of the code base. But anyway, I think it's really neat. We've now got a hasManyReader method that loads and caches associated records, but it also includes all the behavior of a relation. So yeah, pretty cool. Gonna drink water. All right, one last feature. Inverses come into play when you have a pair of related associations that work in opposite directions. Rails calls these bidirectional associations. So the example we've been using, there's a repository class, a pull request class, and we defined a pair of associations, a belongs to and a hasMany pair, that get you from one of these classes to the associated records on the other class. So you can kind of see that these are related. There's a repository pull request and a pull request repository. But right now, there's nothing in our code that actually connects these two things. The reflection objects don't know about each other. The association objects don't know about each other. And that can actually cause some problems. So let's say that I load all the pull requests for a given repository. So that'll perform a query to get all the pull requests with the repository ID that matches. Let's then say I go in the opposite direction in this bidirectional association. I take all those pull requests that I just loaded, and I call the repository method on them. I would expect that to return the same repository object that I started with. It's already in memory. All the IDs match up. We should be able to reuse that same object. But that's not what happens right now. We end up loading the same repository over and over and over. And so we end up with the same problem with data inconsistency that we saw when we were dealing with caching. If I change one of these repositories in memory, the other ones aren't going to see those changes. And this kind of makes sense, because when we first load up all the pull requests, all of the associations for those pull requests are going to be unloaded. So if I then call the repository method on each pull request, it has to load the association, right? Well, we have this other association, the repository pull request association, and its owner is the exact repository that we want as the belongs to association's target. So what if we could just grab the owner from the has many association and shove it over there into the belongs to association? Then we wouldn't have to load it. And that's exactly what we're going to do, and that's what this inverses feature is all about. If we can get these association objects to know about each other, then the has many association can kind of send its record on over to the belongs to. So that'll look like this. When we're first loading the has many associations target, we'll go through each record in that target, so each pull request. We'll look up the repository association for that pull request, and then we'll set that association's target to be the owner of this has many association. So the owner here is that repository. And this works, but I cheated again because I hard-coded the name of the association repository. So if I want this to work for any association, I can't hard-code a value like that. Luckily, this is another question we can ask of the reflection. We can say, hey, if you looked in the mirror, what would the association on the other side? That was a reflection joke. No? OK, that's fine. So like the other side of the pull request association would be the repository association. So I want to define a method called inverse name that will return the name of the association that's on the other side. Might be able to see that that's related to the reflection's active record. So we can write that method by getting the name of the active record, which is going to be camel case, and then calling underscore to make it snake case. That allows me to replace this hard-coded value with a generic value. Sweet. Now if I call repository.pullRequests and load those pull requests, and then I go in the opposite direction and call the repository method on each of the pull requests I loaded, there's only ever one copy of the repository in memory. So we have no more problems with data inconsistency. Yeah, somebody's excited. Love it. Okay. If you've ever wondered what the inverse of option is all about, I should ask, have you ever wondered what the inverse of option is all about? Yeah, OK, yeah, OK. This is it, anyway. It took me years to understand what inverse of is all about. But it's basically about setting up this relationship between associations that are connected. Rails can sometimes guess it for you, but not always. So that's where today's study ends. But it's certainly not where active record associations end. There's all sorts of stuff that makes the real implementation more complicated and more fun to me. There's like through associations, polymorphic associations, all the different ways that scopes can interact with associations, all kinds of stuff I left out. And these are great fun to study. And you have access to the source code. You can go look at this code right now. Just to help out a little bit, this is a big library. So I'll call out some files. Association.rb is where the has many and belongs to methods are defined. Reflection.rb is where the reflection classes are defined. And then the rest of it is in the associations directory. That's the CollectionProxy, the association classes, and some other stuff as well. I also started writing on my blog here about various things that I left out or lied about in this talk. So that may be interesting to you as well. And I don't know, maybe I'll write more if you want me to. I'm also happy to chat with you about any of this. I think I'm also supposed to like share my slides, but I have no idea how to do that. So I'll figure that out and do that as well. My experience has been that demystifying active record associations has allowed me to use them more effectively. I'm able to better leverage features that are built into Rails. I'm able to write less custom code and rely on the code that's already in Rails. Understanding things like inverse of lets me write more efficient code and avoid inconsistent data. Perhaps most importantly, I'm coding more confidently. I understand why I'm writing what I'm writing. Like, why do I need to specify this foreign key here? Why do I need to reload this record here? So the next time you're working with active record, or really any other library, and you find yourself confused by something that seems magical, consider taking a moment to reflect on how that code is working. Studying your tools can help you use them more effectively and can broaden your knowledge in general. I know being a Rails developer is great, but why not study to become a Rails magician? Thank you.